Generics are probably the most important feature of Swift. They let you express algorithms and data structures generically and instantiate with actual types later. This can be done for functions, methods, initializers, structs, enums, and classes. Each one of these has an angle bracket that specifies some type. The type can be thought of as a parameter that is passed at compile time. As we will see, the compiler carries this information about the type all the way from compile time to runtime. Generics are referred to as parametric polymorphism because they allow for the same type of polymorphism of classes and protocol methods, but abstracted across types and not derived classes and conforming protocols. As a simple refresher to how generics work, let's look at the implementation of a stack data structure. A stack, as you know, is a last-in, first-out collection of similar items where you can add and remove using push and pop and inspect the top of the stack. Open the starter playground. In it, you will find a stack data structure. But a stack of what? We might want a stack of integers or strings or CG points. In the starter project, no generics are being used. To support any type, we will use the Swift type any, which acts as a stand-in for any type. You might know that the Swift array actually gives us stack-like operations, but by creating our own type, we have stripped away all of the collection operations that might break our stack invariant. So it is impossible to become internally invalid with this structure. To use the stack, we might write something like this. And I'll run this. The stack gives us a lot of flexibility to store different types, but this flexibility can be our undoing if we happen to push in or pop out the wrong type. Also, since any needs to box the type it holds, there's an extra level of indirection that has a small performance cost. That's where generics come in. To make a stack generic, we'll add the angle brackets with the type. So up here, element is a generic parameter that we are abstracting across. We could name it anything we like T or U, but it's better to give parameters with a clear role, a more descriptive name like element. This is especially true if the name appears far away from the declared location. Next, we replace all of our any types with the generic parameter element. Notice that we get an error at the call site. This is because the compiler now needs to know exactly what type it is and it can't infer it. You can fix this by adding angle bracket int. We also can remove the force unwrap. We can also add an initializer from an array literal. Now we can use inference to write something like this. And run it. What is important to note here is that this is just a shorthand for what the compiler inferred. It still knows that it is a stack of ints, and it uses this information at compile time for better safety and performance.